Yes, welcome dear students. This time I am just delivering second lecture on this differential equations. First lecture I have just introduced the concept, how the concept of this differential equation is generated. Now we will go some definitions. I will give you some definitions. The first definition that we should have, the definition of the differential equation. It is definition. We define an equation involving derivatives of one or more, I will write one or more dependent variables with respect to one or more independent variables is called a differential equation. This is the definition of differential equation. I have used here one, or if I write only involves derivative of one dependent variable with respect to one and only one independent variable, that will be the ordinary differential equation. Here I have used the word one or more dependent variables with respect to one or more independent variables is called a differential equation. Yeah, I have given you some examples here. Examples of differential equations: dy is equal to x plus sine x dx. It involves the derivative. It is y is equal to root x dy by dx. This is the differential equation. It involves derivative. This involves derivative. But here, example number 5, I wrote here x dou z by dou x plus y dou z by dou y plus 2z is equal to 0. It involves partial derivatives, and you have the two independent variables x and y. In example number 5, it involves the partial derivatives. Dou 2v by dou t square is equal to k times dou 3v by dou x square whole square. Here independent variables are t and v, dependent variables are v. These two equations involve partial derivatives, and we say these are partial differential equations. These are only ordinary differential equations when an equation involves the derivatives of one dependent variable with respect to one independent variable. That is ordinary differential equation. I have quoted these examples here. Now let me have the classification of differential equations. Now we have classification of differential equations. In classifications, we classify these into two groups. One is ordinary and second will be partial differential equation. We classify the differential equations into two groups. One is ordinary differential equation. Usually we write in our language ODE, ordinary differential equation. Second will be partial differential equation, that is PDE, partial differential equations. Now what are the ordinary and what are partial? Let us define this. we have ordinary differential equation. In ordinary differential equation, we define a differential equation involving differentials, or you may say derivatives, of one dependent variable with respect to one independent variable will be called ordinary differential equation. It is ordinary. In these set of examples, we can say this is your ordinary, this is your ordinary, this is your ordinary, this is your ordinary differential equation. Examples: 1, 2nd, 3rd and 4th. They involve derivative y with respect to x, one dependent variable and one independent variable, or ordinary differential equations. Now, what are the partial differential equations? We have second partial differential equations. Partial differential equations. It is a differential equation. I am just writing today definitions, because when you understand the definition, then you can logically solve the different. You must know what is, how we find out the order, how we find out the degree, first order differential equation, what is it called, so on and so forth. So this is this lecture today's this is the second lecture on this, and this is something on definitions. A differential equation involving partial derivatives of dependent variable with respect to one or more independent variables. Like this fifth I wrote there, x dou z by dou x plus y dou z by dou y plus 2z is equal to 0. Sixth I wrote dou 2 v by dou t square plus is equal to k times dou 3 v by dou x square whole square. These are called partial differential equations. You see, you have here dependent variable z, whereas you are finding partial derivative with respect to x and with respect to y. So this differential equation also involves derivatives, but partial derivatives. One is with respect to x, one with respect to y, here with respect to t and with respect to x. And in some cases we may have even dependent variable also more than one, and independent variables more than one. So that equation will also, you can also see that equation in heat equation, wave equation in future classes when we go to the advanced part of the differential equations. There we have this dependent variable 1, dependent variable more than 1, and independent variables also more than 1. It is not necessary that you will come across only dependent variable 1. You can have even dependent variables more and independent variable, but the derivatives involving the differential equation will be partial. That will be called the partial differential equations. Actually, the fact is the ordinary differential equation, what we have to deal with it at this time, we will be dealing with ordinary differential equations and their solution. This is our core substudy. I mean, at this time our core substudy is ordinary differential equations, their solutions, their method of solution. Then you will come across the homogeneous, linear, then exact, so on and so forth. All we have to deal with ordinary. Then second part, will go to in the next class, in next semester. That will be the PDE. In partial differential equations, we do those for the advanced part of the differential equations, where we have to solve wave equation, heat equation, Laplace equation, this wave equation of 1 dimension, heat equation of 2 dimensions, so on and so forth. You will come across that later on. This is something about what is differential equation. Now, last time in the previous lecture I have told you how we find the equations that involve the derivatives. There are some equations those involve derivatives, and what is the purpose and what they represent, what the equations represent which involve derivatives. Actually, they represent the family of some curves that I have explained. I don't want to again touch here. Now, today on this lecture number 2 on differential equations, I am now giving you the definitions. What is a differential equation? Simply a differential equation involving the differentials or derivatives of one or more dependent variable with respect to one or more independent variable. If we write only one dependent variable and one independent variable, that will be your ordinary differential equation. If you have more than one dependent variable and more than one independent variable involving the partial derivatives like this, it will be a partial differential equation. Okay, let us now discuss the I will take now order and degree of the differential equation. How we define order and degree of the differential equation. This is order and degree of the differential equation. Let us first define order. What is order? By order of a differential equation, we mean the highest derivative or highest differential coefficient involving in differential equation. Highest derivative or highest differential coefficient involving in the differential equation. For example, I have a differential equation like this. I will write dy by dx whole cube plus d2y by dx square plus 3y suppose is equal to 0. What is here order? Is it 3? No. Order is the highest derivative. It is your first order derivative. It is cube. It is second order derivative. It means derivative of dy by dx with respect to x. It is second order derivative. So we can say order of this differential equation is order is second. Order is second. Then we come across this what is called the degree. Degree. what is the degree? Simple. Degree is the exponent or power of the highest order, involving in the differential equation. For example, this is your differential equation. You have seen it is order is second. This is the order. Now you have to see what is it is power. What is it is power? It should be a positive integer always. It is power is 1. So we say this is the differential equation of order second and degree 1. Okay, let me define first. Degree of a differential equation is the highest order, or we can say here is the order, that is just power or exponent of highest order derivative involved. But it is very important, after differential equation is expressed free of radicals or fractional powers. Radicals or fractional powers. I will write it here. It may not be visible on your video. It is after given differential equation is expressed free of radicals or fractions. That means it is necessary that order of a differential equation can never be a fraction, can never be an negative integer. Order means first derivative, second derivative, third derivative, fourth derivative, and here also you have come to know degree. Degree is always a positive integer. So we will say order and degree of a differential equation is always positive integer. It should not be a fraction, it should not be a radical, so on. We have to first write the differential equation in such a way that it is free from radicals, it is free from this fractional power. Then we can determine it is what is called the degree of the differential equation. Let me write some examples so that you will find the order and degree of the differential equation. I will write here some examples, then we will solve examples where we want to write the order and degree of the differential equation. Let us take this first one. If you take first one, you see the highest order derivative, the highest derivative involved is second order derivative, it is fourth order, this is the first order power 5. Okay, so we say here order is fourth here in this differentiation equation. Order is fourth. What is degree now? Degree, you have to see what is the power of this. I have told you that it should be a positive integer. What is the power of this highest order? Degree is the exponent or power of the highest order involved in the differential equation. Highest order is this. What is it? Is power. It is 1. So we say degree of the differential equation is, degree is first. This is this differential equation. Now let us go to second one. This one. You see, the derivative involved in this equation is only first derivative, first order derivative. It involves dy by dx. Then it is dy by dx square. Means order is first. The highest derivative involved in the differential equation is 1. And what is the highest power of that highest order? Highest power of highest order is 2. So we say in this differential equation, second, it is of order first. It is of order first because dy by dx, not d2y by dx, not d3, dy by dx, order is first, and degree is second. In this case, degree is second. The highest power, the highest exponent of the highest order involved is 2. Let us come here. Third differential equation. You see, it has a fractional power. I have to first get rid of this, write the equation free of the fractional power. I have to get rid of this. How I get rid of this? It is very simple. I will solve it. Equation. My equation is d2y by dx square is equal to y plus dy by dx square raised to power 1 by 3. To get rid of this fraction, I will cube on both sides. Cubing on both sides. It is d2y by dx square whole cube is equal to y plus dy by dx square. And what is the highest order derivative? Highest order derivative is 2 here. d2y dx square. It is highest order. This is first order, dy by dx. So we say in this differential equation, order of the differential equation is order is third. It is of order third. Then you have to see the highest, when highest order is third, is 3. What is the the highest derivative involved here is d2y by dx square. Order is second. I am very sorry. It is second. Order is second. d2y by dx square. It is the order. dy by dx. It is first order. It is second order. Then you have this to see what is the highest power of the highest order. The highest exponent of the highest order. This is your highest order. High d2y by dx square. It is highest power is 3. So it is degree is 3. Degree is 3. Order 2, degree 3. Suppose in this equation, if there would have been d2y by dx square raised power 3 and say some other term plus x times d2y by dx square raised power 5. In that case, degree was 5, but order was still 2. You have to see the highest derivative involved. Let us have this one. We have next fifth part fourth. It is y is equal to x dy by dx plus a times 1 plus dy by dx square raised to power 1 by 2. It is this fourth. How I find out it is order and degree. Fractionals are involved. It will be better if I write this in this way: y minus x dy by dx is equal to a times 1 plus dy by dx again. It is square raised to power 1 by 2. Let us square on both sides. If you square it on both sides, what will be it? It will be y square plus x square dy by dx square minus 2xy dy by dx, then is equal to a times 1 plus dy by dx square. It is a square here. You have write this now. You have written this without any fraction. It does not involve no fraction. It is free of fractions. It is free of fractions. Now how you determine here first order? We have to check what is the derivative involved, highest order. Here you have dy by dx. Here also dy by dx. Here also dy by dx. There is no d2y by dx square. There is no d3y by. It is the highest order derivative involved is first. So order of this differential equation is first. First order. Now we have to see degree. We have to see what is the highest power of this first order. Highest power of the highest order. The highest power of the highest order. Now it is of first order here. It is the power is 2. Here it is also 2. The highest power is 2. dy by dx ka power 2. यहाँ भी dy by dx ka power 2. There is no 3. There is no 4. So we say degree is second. So this differential equation is of first order because it involves the first differential coefficient dy by dx, not d2y by dx square, not d3. So order is 1. Then we have to see what is the highest power of this highest order. No doubt this high order, the first order is here scattered. Here it is also first order. Here it is also first order. Here it is also first order dy by dx. But here power is 1. Here power is 2. Here power is 2. What is the highest power then? Highest power is 2. So degree is 2. Order is first. This is how we determine the order and degree of a differential equation. When we write the differential equation, this free of the exponents, because I have already told you that whenever you find out the order and degree, it is always an positive. It is not a fraction. It is not a fraction. It is a natural number. It is a positive integer. So that is why we have written these two free of these exponentials and wrote it their order. This is all about the order. Next we have to take the linear and non-linear differential equations. We'll be dealing that next. Thank you very much. I will be making one more on this. It is a short video. Okay, thank you very much.